All right, in lesson 9.1, we use simulation to estimate a p-value to decide whether I was exaggerating about my free throw percentage. Today, we're going to use a formula to find this p-value. So to carry out your significance test, we'll always start by writing your hypothesis. So your null hypothesis is that the proportion of free throws I am claiming that I can make is 80%. And then your alternative is it's not 80%. So if we were to have done this, we would have compared values from other classes. So we would have different p-values. So would it be appropriate to use a normal distribution to model the sampling distribution of p hat? Let's justify our answer. So since we're dealing with proportions, we have to check our large count. So n times p, so that is 50 free throws times 0.80, which is 40. And then we have to do n times 1 minus p, 50 times 0.20, which is 20. And both of these are greater than or equal to 10. So yes, we can use the normal distribution to model our sampling distributions. Are there any other conditions we should check? Yes, you know so. We're going to be checking the exact same conditions that we checked with confidence intervals. So can we consider my shots random? Probably for this discussion anyway. And do you think that my 50 shots is less than or equal to 1/10 of all the free throws I have ever shot? We're going to say yes. All right, so now that the conditions have been met, let's find the mean and the standard deviation of the sampling distribution of p hat. So the mean of p hat is equal to p. Now this is all chapter 7 review. And the standard deviation of p hat is the square root of p times 1 minus p over our sample size. So the square root of 0.8 times 0.2 divided by my 50 free throws is 0.056. So now that we have our mean and our standard deviation, and we know we can use the normal curve, our mean is going to be 80 and our standard deviation is 0.56. All right, so how many standard deviations below the mean, remember that's called your z-score, is 0.64. So z is equal to our statistic minus our parameter divided by the standard deviation. Okay, so just in case you forgot or haven't watched the last video, I made 64% of the 53 free throws that I attempted. So that's our statistic minus the 80%, which is, as you can see in number 4, the mean divided by the standard deviation. And that gives us a negative 2.86. So somewhere down here is negative 2.86. Remember, our mean is 0. So let's find the probability of an 80% shooter making a p hat of 0.64. So this is where we do normal CDF, negative infinity, negative 2.8601. If you type that in your calculator, you get 0.002. So what conclusion can we make? Well, that is very unlikely to happen. So if we were really an 80% free throw shooter, remember we're always assuming the null hypothesis is true. So if I really was an 80% free throw shooter, seeing what I saw, seeing that I would make 32 out of 50 free throws, there is less than a 1% chance, if I was really an 80% shooter, of seeing what we actually did saw. So we have convincing evidence against the null hypothesis. We have convincing evidence against our null hypothesis. So you have just run your first test. So the conditions must be checked before you can do a significance test for proportions. We have our random condition, which needs to be met. The independence condition, which we check with the 10% condition, our sample needs to be less than or equal to 1/10 of the total population. And the large counts. Now, these are the exact same conditions that we met with creating a confidence interval. Now, there is a possibility on your AP exam that they will give you a problem where the conditions are not met. And if that happens, then you have to say something along the lines of, okay, this condition has not been met. I'm going to keep going. So every single time you're asked to do a test of significance, please keep doing it, proceed, even if the conditions aren't met. But then in your conclusion, after you write your conclusion, be sure you put some comment about, well, we must be cautious of our results since the blah, blah, blah condition was not satisfied. So let's summarize our one sample test for proportions. This is a one sample Z test for proportions. So we will hopefully have the normal condition met. Our mean, mu of p hat, and our standard deviation of p hat. Our test statistic is going to be p hat minus p divided by this standard deviation. Remember, these formulas are provided for you on your formula sheet. And then once we find the probability of Z, of finding that Z-score, this is going to give us our p-value. So let's do another example. According to the U.S. Census Bureau, the population of students in high school who have a part-time job is 0.25. An administrator at a local high school suspects that the proportion of students at her school who have a part-time job is less than the national figure. She would like to carry out a test at the alpha equals 0.05 significance level. The administrator selects a random sample of 200 students from the school and finds that 39 of them have a part-time job. Let's state the appropriate hypothesis for performing a significance test. Be sure we define our parameter of interest. So P is going to be the true proportion of high school students who have a job, have a part-time job. So our null hypothesis, this is what we're always going to assume to be true. Our null hypothesis is that the true proportion is 0.25. But we're going to test this claim based on something our principal believes, or this administrator. They believe that it is less than the national figure. So we're going to do less than 0.25. Explain why the sample result gives some evidence for the alternative hypothesis. So when this sample was taken, 39 out of 200 actually had a part-time job. So the proportion in this high school is 0.195, and this number is less than the national figure, which is less than 0.25. So that's why he believes that his school has less than what is being claimed. So let's check the conditions. So random. When you're checking your conditions, please name your conditions and then put your check mark. So it says that we have a random sample. So a simple random sample was stated. And then we check our independence. Sample of 200 students, less than or equal to 1/10 of all the high school students at that school. Well, it says that it has let's see. Okay, well, I guess we're going to have to assume that there's more than 2,000 students at the school. I was kind of hoping it would say at a large high school, and then we'd feel a little more confident about that. So we're going to assume that there's more than 2,000 students at this high school. And then normal. So when we do our 200 times our 0.195, we get 39. And then when we do 200 times 1 minus 0.195, we get whatever 39 minus 200 is. Oh, that is totally wrong. Oops. We're supposed to use not p hat, we're supposed to use p. So I screwed that one up, so let's start over. I like it when I make a mistake and y'all can see it. I'm not editing that out because these are mistakes that students make because they just become these little math robots. All right, so we're going to do 200 times 0.8. Why did I do 0.8? Because I am still thinking about our free throws. 0.25. So 200 times 0.25 is 50. And then we have to do 200 times 0.75. And this is equal to 150. And both of these are greater than or equal to 10. So our normal condition has been met. So let's calculate the standardized test statistic and our p-value. So z is our parameter, not our parameter, our statistic, 1.95 p hat minus 0.25 divided by the standard deviation, which is, where'd it go? Oh, I got to calculate it. So we're going to do p 0.25 times 0.75 divided by 200. So when I put all that in my calculator, I get negative 1.797. So let's just do negative 1.8. So when we do normal CDF, so negative 1.8 less than, so we're going to do normal CDF, negative infinity to negative 1.801. We get a p value of 0.036. All right, so what conclusion would you make? So we're going to use the template for concluding a significance test. And remember, your conclusion has 3 things. You need to compare it to the p-value, your p-value to your alpha level. You need to either reject or fail to reject the null. And then we're going to conclude this decision in context. So since our p-value of 0.036 is less than alpha, remember we stated alpha is the 0.05 significance level. So since our p-value is less than alpha, we will reject the null hypothesis. We have convincing evidence to support the administrator's claim that, let's go back up here, that the true proportion of high school students who have a part-time job is less than 0.25. That the true proportion of high school students who have a part-time job is less than the national proportion.